El proyecto Life Ammonia Trapping plantea soluciones a los problemas de las emisiones de amoníaco. Mediante el uso de membranas hidrófobas permeables a gases, hemos conseguido capturar directamente de la atmósfera y también de los medios líquidos el amoníaco. Para ello, hemos diseñado y construido dos prototipos que han actuado obteniendo resultados muy favorables tanto en las naves de animales como en procesos de digestión anaerobia y de compostaje.
Hello.
Hola, buenas.
Hello, good morning. My name is Raúl Moral. I'd like to welcome you all to the second day of the seminar organized by the Life Ammonia Trapping Project. It is a seminar that has to do with new solutions and environmental technologies enhanced or sponsored by European fundings and projects. Today, we will have a presentation of the live ammonia trapping project. We will listen to two of the main researchers. We will then have a round table with a panel of companies who've been involved in this project to see the demonstration and transfer of this live project. And we will then listen to other explanations from other similar projects across Europe that are of interest to us and with which we could create some synergies. At the end of the seminar, towards 12 o'clock midday, we will have an open debate. And well, in order to have a proper debate, we would like to ask you all to submit questions, questions and answers as a functionality so that we can all discuss them. I'm now gonna very quickly show you the live ammonia trapping video, which will sort of as contextualize the presentations we will later on listen to. Thank you. Since 2013, one of the European Commission's objectives is to improve air quality. Several studies proved that piggeries and poultry farms had a big problem that required a solution. All the waste from these animals contains a high concentration of ammonia, which is a gas that causes lots of environmental and public health issues and affects climate change as well. First of all, an excessive amount of said gas in the air affects not only the animals themselves and their health, but also any humans nearby. They harm their respiratory and cardiovascular system. Also, the acid particles that come from the farm react with water and can lead to acid rain in areas further away. That rain can fall down on forests, and with the excess ammonia in the air can cause soil acidification. This greatly harms any animal and plant life of the area. The ammonia seeps into the soil and reaches groundwater, which will also affect the ecosystem. The ammonia trapping membranes turn these problems into a double solution. Their special walls can trap ammonia that is either in liquids or in the atmosphere. Inside the membranes, the ammonia is combined with sulfuric acid and creates ammonium sulfate, a high-quality natural fertilizer. Therefore, ammonia trapping is an ecological solution since it reduces the emission of a toxic gas. And an economical solution because it turns waste into a fertilizer that farmers and ranchers can take advantage of. Ammonia trapping. Thank you very much. The video is really good, how simply everything is explained, bearing in mind that this is a complex project. So, having watched this video, I'd now like to give the floor to Ms. Mercedes Sanchez Vascones. She is a lecturer at the University of Valladolid and a great expert in waste management, and she's also involved in many scientific networks that work in the field of agricultural sustainability. So with any further ado, Mercedes, I give you the floor as the main researcher in this project. Good morning, ladies and gentlemen. My name is Mercedes Sanchez Vascones. I am the coordinator of the waste management research line within the HIT Tadros renowned research group. This is part of the High Technical School of Agricultural Engineering in Palencia. Within the partner panel, I've been in charge of the live ammonia trapping project, particularly in charge of monitoring the prototype we've created. The problem of ammonia is a problem well known to all of us in the farming and agricultural industry. Ammonia is responsible for 96% of ammonia emissions in Europe. Within this percentage, 62% comes from the way we manage manure and slurry in different management or handling stages. We can talk about the housing stage, the storage phase, or the infield application stage. We also know and have heard about other ammonia-related problems like bad odor, water eutrophication, soil acidification, and the creation of PM2.5 and nitrous oxide, which is 298 times more powerful than what is caused by CO2. Reducing national emissions of some air pollutants is something that's regulated by the Protocol of Gothenburg and also the NEC Directive, Directive 2016-2284, which is also known as the Ceilings Directive. They both established a maximum gas emission limits for all member states since 2010. For Spain, sorry, an emission ceiling reduction of, well, that should come down to 353 kilotons of ammonia is established. This involves a 3% reduction in any period between 2020 and 2029. Also, a 16% reduction for years after 2030 is established. If you look at the tables here that have been published by the Ministry for Ecological Transition, we see that reduction commitments here. If we look at the ammonia column, you see that in 2020 we're not complying. And you see that the forecasts for 2030 also show that there will be no compliance. So the solution we propose from our project is to develop some kind of membranes to reduce ammonia emissions, particularly the ammonia generated by swine and poultry manure or excretions. This project was submitted to the Subprogram for Environment, the LIFE program, in the EU within the thematic priority for air quality and emissions. You see the consortium, the partners that are part of the project. The project is coordinated by the University of Valladolid through its Fundación General, its general foundation, and there are two main partners which are technical coordinators. This is ITACIL, the Agricultural Technological Institute of Castile and León, and the university, so the HIF Taurus, that's part of the High Technical School of Agricultural Engineering in Palencia. We then also have three partners which represent the places where the experiences have been conducted. We have a swine farm, De Porcil, a poultry farm, La Cañada in Soria, and Enusa, which is a company that's publicly participated and that had an anaerobic digester in Salamanca, and that's where we've conducted the tests. We've also got Inderen involved. This is an engineering company which has been involved when developing the prototypes. The main goal of the project is to offer an environmental, economically viable solution to reduce ammonia emissions. We want it to be, as I said before, environmentally friendly and economically viable and sustainable as well. To achieve this goal, two prototypes have been developed. In the liquid prototype, we've basically insisted on or focused on things regarding manure and slurry storage. So we've been very much involved with reducing space required for storage. Otherwise, well, due to nitrogen limitations, we could have some problems. And in the case of animal housing, we've used the gas prototype, and we wanted to have an impact on this other part. The gas prototype works through a membrane. It is a waterproof, gas-permeable membrane, and there's a permanent flow, closed circuit circulation of an acid solution within that membrane. There are other acids that work with it, but we've mainly used sulfuric acid. The gas molecules that were found in the atmosphere, in the air, can go through the membrane walls, and once they come into contact with this acid solution, they are trapped by the acid and they are fixed as an ammonium salt. So what we're doing is we are transforming the molecules over here into a nitrogen fertilizer. The gas prototype basically consists of a container with some membrane panels. You can see them in the slide. And as you can see, the membrane is sort of in a zigzag shape so that we can use less space to obtain the same result. You see all the panels over here inside, all of them are connected to a sort of gutter or channel at entry and exit points for the solution. We also have the setup panel here. Through this, we can monitor and control all the variables we have established throughout the project. We also have this tank for the acid solution, the pump, and a ventilator as well as sort of fan, which in the case of the swine farm, because the prototype was installed inside the farm, what we had was a sort of air propulsion towards the membrane panels. In Soria, in the other example, there was a tube that absorbs all this flow. Let's have a look at a short video to see how it works. This is the tank where we have the acid solution. It is a 250-liter tank, which contained, well, the experience was conducted with about 150 liters. You see how we use the pump to propel the acid towards the channels, the gutters where the prototype is located. The acid flows with a variable flow velocity. We can change that speed based on our needs. And it's propelled towards this gutter up here. You see the main gutter and all these small tubes that somehow send the acid towards the different panels. The acid can therefore circulate throughout all the panels, and within those panels we have an ammonia mixture or alloy that produces the final effect. It goes through all the panel and then comes out at the other end from the panel towards this other gutter that collects the final acid with the fertilizing salt and can then be recirculated towards the acid solution. As you can see through time, as this process moves forward, you see that the solution becomes richer in ammonium salt and it sort of loses its acid features. You can see some more pictures here. And if we want to have a look at the air circuit, in this case, this is a closed discontinued composter. We have connected the tube to the composter atmosphere. It suckles the air towards the prototype in such a way that this air can circulate through all the membrane panels, and at the exit point, once the air is cleaner, freer from the ammonia levels we had at entry point, you see that at exit point it is recirculated once again towards the composter. And once again, we have a closed circuit, as we saw in the previous case with the acid solution. The atmosphere prototype has been used in 2 different locations. There was one in 2018, 2019 in a swine farm in San Pedro de Cansoles with these characteristics that you see here. And later on, it was transferred to Soria, to another farm, Aldea La Fuente. This is a poultry farm, and it was used there from 2019 to 2020. Over here, we have some experiences inside the farm with the prototype. In the poultry farm, it was placed outdoors, placing the pipes over here out of the unit with some pipes here that suckled the air and produced all the prototype absorption features. Here you can see some of the um, most highlightable results. In Guardo, for example, in the swine farm, you see that you see TAN values after few days, how it increases on average. And well, this is clearly indicating that daily absorption, because there's no change in the line curve, is more or less maintained. We've seen differences if we look at summer and winter, by the way. This is a natural ventilation farm. So in the summer, it was practically always ventilated. So ammonia concentrations within the unit, within the farm were lower, and absorption was lower as well. So we saw the differences, and we saw that there were some uh, days with 112 recovery rate in summer, whereas in winter we've had peaks of up to 616 milligrams per day. So that recovery rate per square meter of membrane was also different. These are the control parameters. You see how pH increases progressively, continuously, as the solution becomes richer in ammonium sulfate. We had to correct this twice so that the pH was not above 2, and so that we could use the maximum efficacy in recovery. In the case of electrical conductivity, which was another parameter we analyzed, as the ammonium sulfate was enriched, there was a decrease in electrical conductivity. This decrease was quite a straight line as well, and it allowed us to monitor TAN concentration levels in the acid solution through measurements such as that of electrical conductivity. This allowed us to therefore um, make the process more automatic. In the case of the poultry farm, we also found some differences between summer and winter. This is a hen farm, a layer farm. We see how the prototype is outside the farm but connected to it, and because it is a fresh range layer farm, well, we had some doors in the lower part of the unit, so that during summer they were mostly open, and concentration levels inside the farm were very, very low. They never went beyond 10 ppm. So this is why we see these recovery rates very low. In winter, doors were closed more frequently than in summer, so recovery rates were, as you can see, quite different. This is a summary of the results. In the case of composting, um, we've seen the process before. Because it was a closed circuit and the composting was done this way in a closed circuit, we've achieved nitrogen recoveries. Well, if we find the balance between the initial content in the hen droppings we analyzed and the final content, and also looked at the recovery part, well, levels were 76.4%. In the case of Guardo, we also had quite interesting recovery rates. In the case of Aldea La Fuente, it was not so interesting. Well, basically due to the way we exited the outdoors yard. We've also conducted some experiences in terms of assessing the final product. We have characterized it first. It's a colorless liquid with 3% nitrogen, more or less, so 14% of ammonium sulfate and 8.5% of SO3. We've tested its efficacy, comparing it to a commercial fertilizer in a greenhouse. We've used this in a spinach sample. So we've tested this and conducted some experiences. And then also outdoors, we've applied some treatments with wheat crops. You see the different doses here, different treatments applied, and the results. So looking at all this, the assessment, the final product assessment clearly shows that, well, results are very comparable when it comes, or when we compare the usage of a commercial fertilizer with the same dose of a farmyard manure. For some of the crop parameters we've assessed, we've measured, not only in terms of number of plants, but also in terms of weight of above ground and root systems. Well, we've seen that in some cases, farmyard manures were better in terms of yield and performance than commercial fertilizers. Here you see more data for the wheat trial. You see before fertilization and afterwards at crop level. And what we've seen, you can see a summary of the results here. In the case of the fertilizer, we tested 3 doses comparing the commercial fertilizer with the farmyard fertilizer and 2 control groups. Well, you can see this is the farmyard manure. And if you look at this example, wheat production was higher than that obtained with the commercial fertilizer for the same dose. In the case of number of grain and parts of plant, you also see the details here. So the conclusions we can obtain or we can draw from this, if you look at the gas prototype, is basically that we've been able to get rid of 13% of the ammonium nitrogen released in a composting process. We've recovered 76% during the 44 days that the process was conducted. Also, we have estimated that we can recover 74% of the ammonia in the atmosphere in the swine farm and 39% in a poultry farm during the days that the prototype was working there, was in operation. We've also obtained a high value marketable fertilizer with results that can be comparable with commercial fertilizers. And well, that was all from me. Thank you very much. And if you have any question, I will be more than willing to answer them. Thank you very much. Mercedes, we will have the questions and answers round afterwards at the end of the session. Therefore, we can have time for people to submit their questions through the questions and answers functionality. And now I would like to give the floor to another of the main researchers, Maria Cruz Garcia Gonzalez. She's a researcher at ITACIL, the Agricultural Technological Institute of Castile and Leon. She's been working in nitrogen capturing systems for many years, so she's a great expert in this field. I'm sure that we will all enjoy her presentation. So Maria Cruz, you have the floor.
Thank you very much, Raul, and thank you to the participants for taking part to this final workshop of the ammonia trapping project. I'm going to present to you the work that we've been conducting throughout these 4 years with the liquid prototype, and I am going to give you some explanations about how the technology of gas permeable membranes works. As for digestate and slurry, ammonia can be found in 2 different molecular shapes, in the shape of ammonia and in the shape of ammonium. The balance between these 2 forms is governed by the pH and temperature parameters. These are very important parameters when it comes to working with prototypes of ammonia trapping. In this slide, you can see in the top part of it at the top right corner, you can see the membranes we've used. They are tubular membranes that we submerge in slurry or in digestate, depending on the substrate we're using at the moment, in that moment in time. In this case, slurry has a basic pH, and also the digestate tending to basicity in a way such that ammonia and ammonium tends to turn into ammonia. It's a characteristic of these membranes. We try to favor the movement of this balance towards ammonia by increasing the pH of slurry and digestate, so that we have a greater level of ammonia in the middle, and the membranes can capture this more efficiently. This is a scheme of a graph of the membrane. This is the external part with the slurry. This is the wall, and this is the inside part of the membrane. Inside the membrane, there is an acid solution with sulfuric acid diluted. And in this case, ammonia that can be found in slurry is able to go through the membrane, since it's a gas permeable membrane, and it's combined with sulfuric acid that runs inside and flows inside. Therefore, it turns into ammonium sulfate. This is a fertilizer, and we have used in our studies at the university for fertilization that Mercedes has already presented. In this way, we managed to reduce the ammonia in the liquids and turn it into a fertilizer. In this project, we have worked in two different locations. We have worked in a farm that is located in Guardo, in the northern area of Palencia, the province of Palencia, in the center of Spain. We have worked with digestate in Jurvado, in a biogas plant in Salamanca, the province of Salamanca, in the center of Spain also. This is the Guardo farm, and I'm going to show you where we were getting the slurry from to work with it. This is the farm, as I have already said, and this is the tank for storage of slurry, and this is the container where the prototype plant is located. You're going to see it in another video more in detail. This is a tank for diluted sulfuric acid, which we use to concentrate ammonia. This is a scheme of the inside of the container. Uh, there is a 5 cubic meter tank with slurry or digestate, 16 membrane modules with 13 square meters of membrane in total. And here you can see one of the membrane panels. This is one of the panels that we have used, and the membrane is, as you can see, in a zigzag shape. As you can see, we have the tank here for the acid, sulfuric acid solution containing 250 liters. We recirculate the solution from here continuously towards the inside of the membrane modules. It has also, this pilot plant, a display where we monitor the pH of the slurry and also the pH of the sulfuric acid, since this monitoring is very important, as I'm going to explain to you a little bit later today. This is the channel to recover sulfuric acid coming from the panels, and we use this channel to give this sulfuric acid back to the 250-liter plant tank. All of the plant is governed by a PLC, which controls the pumps and the timing of the pumps. Now I'm going to show you a video where we will be able to see more in detail the different components, the various components of the pilot plant. This is the device that we use to pump air into the slurry tank. Why do we pump air in? Because we are interested in making the pH go up, the pH of the slurry, so that we can turn the balance between ammonia towards ammonia. How do we do this? By aeration. So we can increase the pH of the slurry up to 8.3, which is the pH that we want to have. This is the 250-liter tank containing sulfuric acid that we recirculate continuously towards the inside of the membrane modules. This is the display that enables us to control and monitor the process and the pH of slurry and sulfuric acid, since it is very important to keep both pH levels under control. This is the slurry tank containing the submerged membrane modules, which are submerged into the slurry or the digestate. And as you can see, we recirculate the contents of the 250-liter tank. It comes through this channel, and it is distributed in the 16 different channels through this pipe. And this sulfuric acid, once it's been turned into ammonium sulfate, it's recovered by these other pipes, these small pipes, and all of it is recovered by another channel that I'm going to show you Now, this is the other channel where we get the ammonium sulfate coming from the 16 panels in a way such that through this channel, this is sent back to the 150-liter tank and is therefore recirculated continuously. This is the recirculation pump for slurry, since if we are to keep homogeneity in slurry, we need to recirculate it. This is the most simple way to recirculate the homogeneous slurry that we have found. This is the most simple way that we have found. This is the pump. This is the ammonium sulfate that is ready here to be distributed. And this is the PLC that controls the different devices, the pumping devices, etc. In this case, I'm going to show you a video of one of the workshops that we held in the biogas plant. In this case, the prototype is located over here, and here on the floor, there is a tank for the storage of digestate coming from the digesters of the biogas plant. So we located here because it was more convenient. We can pump the digestate into the plant from here. The plant is just like the one we have seen in the previous videos. They are the same prototype. Regarding functioning, the results that we have obtained throughout the project, we have worked in Guardo 128 days, and we have worked in 177 days in Juzgado. We have worked with batches, which is more convenient than working continuously, and batches from 7 to 20 days. In Guardo, it took longer to set this process in motion because we needed to make some adjustments in the pilot plant. So the setting in motion of the process was a bit longer in Guardo than in Juzgado. In terms of, we have used batches, and they have lasted a number of days in the different batches. So the various batches have enabled us to study different parameters to be used in the plant, from maximum elimination, pH, just to analyze the level of pH that would enable us to capture more ammonia. And we have used different batches for this because it was simpler like this. We have an example of the initial pH levels and final pH levels, which, as I have already said, is very important, pH levels, and both for fresh slurry and for anaerobic digestate showed similar levels, 7.3 to 7.8, and 7.3 to 8.3, and as for the final pH level, it was from 8.2 to 9. We tried for it not to be very high to avoid volatilization, because we want the balance to turn towards ammonia and for the membrane to trap it. But if this pH is too high, then we get volatilization, which is what happened with some of the batches that we have studied. This is one of the graphs, typical graph of the studies I have conducted, where the elimination of total ammoniacal nitrogen changes. These are the typical graphs that we get in this type of studies. As you can see, both for Guardo and for Juzgado, both with slurry and for digestate, the TAN has been very similar between 2.3 and 3. The eliminations has gone from 15 to 52% in Guardo and from 27 to 48 in Juzgado. It's been a bit higher, slightly higher in Guardo due to the fact that the pH level of of slurry has been slightly smaller. It didn't go up that much as in Juzgado, so we had a smaller level of volatilization with slurry in Guardo than in Juzgado with digested. As for nitrogen recovery, we managed to have a final concentration around 32 gram per liter. The recovery level in Guardo was between 42 to 80, and in from 32 to 55 in Jutpado, the TAN recovery. We This is due to the fact that the pH levels was smaller in Guardo. Regarding the TAN recovery maximum rate, we have the data on the screen. Regarding the characteristics of the solution of the obtained ammonium sulfate solution, it's a colorless liquid. It doesn't damage the membranes. It complies with the regulation of the European Union. It's easy to transport and to pump. It has a neutral pH. It has a 3% concentration of nitrogen, so we can use it for irrigation, and it has mineral traces of minerals. We think that this is an interesting solution to be used in fertirrigation, since it has a 3% concentration of nitrogen, and we have managed to, well, we have not studied the option of concentrating this product, since this was not one of the objectives of the project, but we think that this could be concentrated, and this could be used to turn it into a liquid shape and then concentrate it with a view to having a solid fertilizer, depending on the preferences. Regarding the life cycle analysis, we have a preliminary study, and we are at the moment conducting a comparison between the traditional conventional treatment of slurry, including transportation, storage, and in-field application. And we're comparing this to the treatment of slurry using membrane technology, including storage, nitrogen recovery through the extraction of ammonia, transportation, and application. At the moment, these are preliminary stages for these studies, but we are starting to see that we have a small reduction in terms of the climate change parameter by 7%. And in terms of eutrophication, we see that we are managing to reduce this parameter down to 23%. So this may have the reduction of impacts might be quite interesting. We are convinced that we are going to obtain good results also in terms of other parameters that we have studied or that we are studying. Conclusions: we have achieved eliminations of 31 to 52% of TAN in approximately 9 days, recovery of 54 to 80% of TAN in approximately 9 days. We have concentrated TAN concentrated 10 times in approximately 9 days. So we have a product that can be used for fertilization, and we are studying the reduction of environmental impact with this technology by means of the use by means of the study of the use of ACVs. Thank you for your attention. I hope you have found this interesting. Thank you. Thank you very much, Maricruz. That was like magic, really, to be able to extract a gas from a dirty liquid by making it get in contact with some of the liquid that captures and traps nitrogen. It sounds like magic, and it's very inspiring and motivating. So congratulations. I think that it is timely now to hand over the floor to the people who have been working in the field regarding this project and has taken part in these different stages of the project. And the participation of the sector, of the industry, is very important at all times. And so now I'm going to hand over the floor to Mr. Alberto Alevianton, who is the technical director of the Porcil company, Desarrollos Porcinos de Castilla y León. That's the name of the company in Spanish. And this is, well, they are located in the area where the prototypes were tried. First trials of the prototypes took part in this area. So I now hand over the floor to Alberto, who's got 10 minutes. Thank you, Alberto. You have the floor.
Good morning. My name is Alberto Levia, and I'm the technical manager at Deportil, a livestock farm which conducts its activity in the province of Valencia, in the north of the province, in the surroundings of the municipality of Guardo. To give you an idea about the size of our company, well, we have 3 breeding farms, each of them with 2,800 sows, and with a capacity for about 45,000 pigs. We need about, well, more than 100 staff to work in the farm. And well, it is a challenge to explain a project like this one in a very short video like this one. It's difficult because it's not only this 3 year of performance of implementation of the project, but also prior conversations that we had and that could sort of have led to such a project. When Deportil started working in the area, one of its main concerns was environmental management issues. So we contacted people that we considered experts in the field and who knew more about this. One of them, who's helped a lot and with whom we're constantly in touch, is Mercedes Vascon, who's a lecturer at the University of Valladolid. In our daily work, we've always had many doubts about agro-environmental management issues. So our conversations were very interesting. In fact, probably some of them were the seed of a project like this one. Deportil has always wanted to be a partner in a project like this one. We didn't want to be guests invited to the party. We wanted to be an active agent, to play an active role and to place solar farms to the service of a project like this one. This may be complex at the beginning because our facilities are not ready for research activities, but I'm sure that with the commitment of all our people and staff, everyday difficulties have been overcome. So despite the difficulties, I have to say that this has always been really advantageous, always taking part in a project like this one. On the one hand, it's allowed us to be closely in contact with the administration and explain to them what we do. And not only what we do, but also ask them what we want from them and report what we do daily. Our dialogue has been really fruitful, always with the help of experts like Mercedes, who've given a lot of credibility to our daily work. So this is why it's important that at all times, companies are available for research, and it's important that we make whatever resources we may have available to researchers so that they can carry out their initiatives. Right now, well, this is a project about ammonia emissions decrease. And well, for us, this has not been simply an initiative to comply with the NEC directive. This can be a limiting factor for the future. It's true. This is why we're working in this now and in the future, but this is not the only thing we've considered. Ammonia reduction in farms like cows means an environmental improvement for all of us, and that is gonna be, it's gonna mean that our staff can work in better conditions. Also, the fact that there are better environmental conditions is also a fundamental part of, well, our daily work to comply with animal welfare measures and regulations. This is part of our job, and well, this project has also made this work easier. This is not our only goal. Apart from this, I think that we also have to look at the future and try to make projects like this one somehow be compensated by the way we work every day. I think that our struggle by farmers so that our activity is seen, um, well, not simply as an activity that produces pollution. Well, this is it's starting to be seen as something that can produce opportunities. Let me explain myself. We as farmers understand that to conduct a farming activity, we need to be closely related to all the stakeholders. We need to be closely related to farmers and to producers, to breeders, not only with farmers, but also with people working in the field of agriculture. We can have many interesting projects with them. And what we've seen is that when things are managed adequately, we can be very valuable, a valuable input for their crops and for their activities because we can reduce their fertilization costs. It's also important to work with farmers and breeders. We've worked in pastures where we can do some specific activities and we can allow farmers to maintain their exploitations better and maintain their herds for a longer period of time, something that's essential to prevent environmental damage. So, as I was saying, our vision towards the future, something that starts in projects like this one, is that this should not end here. I think that Deportil has already shown that we are committed to working in projects like this one always, because our idea is basically that, well, it's focused on two main ideas for the rural area. We're talking about livestock and agricultural production. Both are very important. Both require a very important and close by labor force. So for the future, this would help us reduce depopulation levels and many other things. If we can reduce depopulation levels, for example, which is of great concern today, if this can be, if what we do can be one of the possible solutions, not the only one, but one of the many solutions, we could that depopulation situation, a strong farming activity that is sustainable, competitive, uh, which can allow us to obtain fertilizers nearby and then help agricultural farming, well, this will make all these farms and the industry as a whole more viable. And it can also help extensive farming so that in grazelands and pastures, we can apply these fertilizers to feed more livestock for a longer period of time. This should be enough incentive to continue pursuing our idea and our efforts of, well, what we initially thought with a project of this nature. We want to find the way to manage slurry, to generate, in some cases through direct application, in other cases by generating molecules that can then be applied in agriculture. The idea is to facilitate and strengthen both activities, agriculture and livestock production. So this is why I understand that for companies such as ours, these type of initiatives cannot be seen in terms of costs only. I think that everything we've done here is investment purely. It will be multiplied, I'm sure of it. It has already taken place and it will continue to be so. And in the future, the idea is that we will reach a scenario where both agriculture and livestock farming overlap perfectly well in an area like this one we are operating in, the mountainous area of Palencia, which has a high ecological value. So as I said, I hope activities like this one and projects like this one are just the beginning of that final solution, which is drawing nearer every day with initiatives like this one. Thank you very much. Excellent, Alberto. We would like to thank you from here for your involvement with the project as a representative from the sector, from the industry. It's really gratifying to see how you're implementing this type of solutions. I'd now like to give the floor to, well, continuing with technological development advancement. Once the prototype was validated in Guarda, the different modules and membranes were transferred to companies like Enusa. Enusa is a company that basically applied the technology available to treat digestate coming from a biogas plant in Juzgado, Salamanca. So to present this solution or this application to us, we have with us Mr. José Luis Girón Vázquez. It's your turn.
Good morning to all of you. My name is José Luis Girón, and I work as a technical manager at ENUSA in the Life Ammonia Trapping Project. ENUSA is a public company that is with 60% SEPI participation and 40% SEMAT participation. Our activities are divided into nuclear and environmental business, and I've been asked to talk about the reasons for investing in research and development for ammonia emissions reduction. Well, when one of our partners suggested taking part in a consortium for a live project related to reducing ammonia emission from liquid discharge in our biogas plant in Juzgado, we found this idea very interesting and in line with our environmental business. At ENUSA, our hallmark is integrating the latest technology into our services and processes and equipment in order to improve both the final product that we offer clients, as well as our levels of quality and environmental security. We firmly believe in innovation as a way of creating added value, and we carry innovation in our DNA, in our blood. Is why at ENUSA we assign 6% of our sales, we allot 6% of our sales to research and development. And what are my experiences and advice to those who would like to participate in a live project? Well, the first of this is that the business organization who would like to take part in a European Commission project should know that there are significant administrative demands with deadlines which enter into conflict with everyday work tasks. Secondly, my advice is not to conduct an innovation activity if the aim is only to get a grant or to get funding. A project like this should solve a problem in your company, or at least a problem of society. The effort and dedication is big. It's too big to end up having the final project locked into a cabinet like that. Thirdly, carefully select the consortium partners you would like to work with, as in 3 years, we might find one of the partners has, I don't know, for example, financial problems, or that you get dissent in different opinions, that you get discrepancies in terms of the actions to be carried out. This was not our case, but it could happen. Fourthly, in a project like this, management and dissemination activities and duties are very demanding. So our experience in a live project, and it's the first we do at ENUSA, has been very good, has been unbeatable. Would we change things? Of course we would, because, for example, we would certainly carry out financial aspects in a different manner, probably, yes, surely, actually. And last but not least, why is it important to reduce ammonia emissions? Well, we all know that ammonia is a toxic gas, and when we enter in a piggery, in a pig farm, or in a livestock farm, we suffer breathing the air that is in there. So this gas creates health problems for both workers and animals. But apart from that, ammonia is released into the atmosphere or is diluted, polluting land and water nearby. As owners of a biogas plant, which greatly values, which attaches great value to pig slurry, and in a region with a great number of intensive piggeries, we know firsthand the real problems of the land, water, and the atmosphere with which are generated by excrements, livestock excrements, or the accidental spills that might happen. This is why this technology presents a number of advantages, such as reducing odors, it reduces volume and land required to apply this product, which in both biogas plants and also piggeries. Secondly, it reduces the inhibitions of the anaerobic digestion process. And thirdly, it reduces indoor ammonia concentration, improving therefore the quality of the air and obtaining a smaller frequency of ventilation, which means significant savings. The trials of the liquid prototype at the Hurtado biogas plant have been a success. And these results are going to be presented by our staff at the UVA and ITOSIL. With the few development improvements, the future of technology could be relevant, and it would offer a low-cost system to treat farming excrements. This project not only contributes to the sustainability of the environment in the primary sector, but it also is an important factor when it comes to generating wealth in the rural areas, providing solutions to the needs that intensive farming activities generate in a way such that it also has pledged its commitment to the circular economy of residue and waste and sub-products. It also makes a rational use of natural resources, and it reaches sustainable, or it contributes to reach sustainable development goals. I would like to thank our project coordinator, the General Foundation of the University of Valladolid, and also would like to thank the partners of this project, and of course would like to thank the European Commission for giving us the opportunity to work in an innovative project which can help to foster sustainability and to promote a circular economy in the European Union. Finally, I would like to leave you with a presentation of our facilities and how the prototype actually worked in our biogas plant. Thank you very much for your attention. Here you can see an image of the entrance and the rear exit of the biogas plant. Here's a brief diagram of the process. The facilities where the liquids prototype is located at the Enusa Juzgado plant in province of Salamanca in central Spain. The inside of the liquid prototype during operation can be seen in this image. Here we can see the prototype, the SCADA prototype with different parameters. And here's an image of the workshop that we held in Juzgado. And here we can see some pictures of the various meetings that we held with the partners of the project. Thanks very much for your attention, and well, have a nice day, all of you. Thanks very much, Jose Luis. Now we're going to move on to the next part of today's session, and we're going to have a look at the functioning of the prototypes in the lion hands farms. Here with us today is Jesus Tiria de la Fuente, who is the head of Avícola Thiria company. This is the name of the company, Avícola Thiria. He's got 10 minutes, so you have the floor. Thank you.
Thank you very much. I don't know whether you can see me properly. Okay. So, first of all, I'd like to start by thanking the moderator, the coordinator of this panel for this introduction. And well, my name is Jesus Tiria de la Fuente, and I am the manager, the managing director of Avícola Siria, a poultry farm. We basically produce and market free-range ecological eggs. And well, I'll later on show you some pictures so that you can see the location of the prototype in our farm and the way we've proceeded with air absorption techniques, etc. We're a small company, only 6 members of staff, 6 employees who basically produce alternative eggs. And I'd like to highlight this because we will see that pressure on environment of this type of agricultural and of farming production is lower than the pressure than any other hen farm, poultry farm, which is totally industrial, totally intensive, can produce. So, although the results are not the same as those in a swine farm, more intensive, with the prototype, I mean, well, you'll see the results we've had, well, taking into account our installations. We can achieve a ventilation and atmosphere and air condition within the units housing the animals with a, well, you'll see that ammonia levels are very low. Why did we enter this project? Well, first of all, because we like to participate in all research projects always. We thought that this was a very interesting project for this point in time in terms of, well, the legislation we have ahead of us, a legislation which is trying to favor environmental protection, animal welfare, legislation which is trying to improve working conditions for any kind of job. Well, in farms, I think it's one of the places where there's a still place or room for improvement. So, well, taking all this in mind, we thought that, well, this was a good opportunity to look at the future and, well, think about what's there to come and where we will get to through the legislation we have. And through the legislation, many of us are requiring for a more environmentally friendly, sustainable situation. So in projects like this one, what we see is that apart from all this environmental improvement, we're clearly seeing that there will be lower ammonia emissions into the atmosphere. This is good news. We're going to reduce acid rain levels, as Mercedes was referring to before. And with projects like this one, we will also see an improvement in air quality and the air quality of the air breathed by our animals and our employees. So this is things we will achieve, and we'll also achieve with systems like this one, the possibility of giving an added value to a byproduct or to a residue, a waste that's being generated in many of our farms, an added value which can then benefit farmers. In the end, what we want is to make our facilities economically viable. And well, with a process like this one, it's clear that we can actually achieve the added value. We are obtaining a fertilizer which we have to produce chemically otherwise. That would involve more energy waste and expense, a higher economic cost, etc., etc. So with this, we're already clearly offering a product to farmers that may be more economic, uh, cheaper for the viability of their facilities, of their farms. And well, in the end, this will means improving our circular economy and our systems. I'd also like to indicate that well, these projects have a very huge administrative burden, lots of red tape, so to speak, which, well, thanks to the university, we've been able to go through more easily. I'm going to show you some slides now so that you can have a better idea of where the prototype was located and how it was operated. And well, with those slides, I should also be able to explain things to you better. And also, I'll try and explain why our results were not as good as those obtained in swine farms or in liquids. So I think it's going to help me give you a better idea. Let me see if I can share my screen. I don't know whether I've managed to do so. Not yet. They're trying to give you access to the share screen functionality. So what we will see in the slides I'll show you is that, um, well, the ventilation, thank you very much. Okay, it seems to be ready. Let me see if I can now share my screen. So what we will see are facilities that are very well ventilated. So concentration levels, particularly in the summer, because in the winter, even if animal exit traps are open, windows are closed, and we just have minimum ventilation levels through some chimneys or chimney stacks placed on the roof. Okay, I've already managed to share my screen. So there we go. Here we can see the slides. This is the surroundings, the area around the unit, the farm where we've placed the prototype. You see that the windows are right on top of the exit traps. Exit traps, you see they're open, but the windows are closed. Over here, you see a summer picture, how windows are totally fully opened. And in the winter, they are closed. This is indoors, where we're going to have the air capture ventilation system. And below this, we will place, well, this is where we will have 90% of animal excretions. You see the tubes and pipeline system that goes underneath the facility for extraction towards the prototype, air inlet. I think this could have been improved. Obviously, it's something that we've seen at a later stage. It's true that if we improve air capturing systems, our air capturing system, we will undoubtedly improve ammonia trapping possibilities. And here you see the housing system. You see that most of the time the hens are on top of those slabs. And you see where the poultry droppings are mainly deposited. This is the prototype. Well, I have to say that for me, when we managed to place it here, this was a very important issue because it was outdoors and it was easily handled from outside the farm. So my conclusion is that the more intensive a farming system is, and as we all know, we need intensive production systems to be able to feed such a huge population and to offer food at a lower price so that everybody can have access to that food. So we're going to need this intensive production system. So anything we can do to improve our environmental conditions, anything we can improve when working in terms of labor conditions, anything we can improve in terms of animal welfare is going to be of huge impact. The added value we offer with these to farmers is also very relevant, and it's going to be a highlight. The added value we're going to offer to agriculture is going to be one of the main points as well. The way our society will look at farms is going to be another issue we'll have to pay attention to. As I think somebody mentioned this before, it seems that farmers only come to pollute the environment and rural areas. That's typically said, while, well, in the end, many of us farmers are actually preserving rural areas like the one I live in. So, and helping avoid depopulation processes. So for me, this project is a great success and really useful. The results obtained have been very good, I think. We're talking about prototypes, but I think that well, anything we can improve, well, all the best. But I'm sure that our figures will be better, and our bottom line will be better in the end. And well, I think, and that's my own opinion, that very soon by law we should be all asked to use systems like this one to be able to work in the livestock industry in Europe. Thank you very much, Jesus. Well, it's true that it seems that the industry like everything that has to do with research and applied technology transfer, and this is very interesting. So now I'm going to give the floor to Mr. Ricardo Romaguera Faura. He is the managing director of Inderen. It's a company involved with engineering and renewable developments, and this company has been involved in the development of the engineering and the these engineering parts of the prototype. So Ricardo, if you can explain to us what your role has been and your feelings.
Good morning, can you hear me? Yes, we can hear you. Thank you. Uh, Good morning, my name is Ricardo Romagara Jauba, and I am the founder of the Ingenierías Renovables company. From its inception, this company has worked with the design of renewable energy plants. In this sector of renewable energy, we are one of the Spanish companies more experienced in the field of installation and building of biogas plants. From its inception, Indurain has based its growth plan in the continuous innovation of its products and services. Proof of this is that in 2010, we got the certificate for the UNE 166 2002 for our research, development, and innovation. And then we have some more certificates from the Spanish authorities. We have taken part in programs and projects of research, development, and innovation since 2010, and we can highlight the following projects: Life on a Dry. We took part as a partner of the consortium, and we took part of the design, building, and maintenance of the pilot plant that was used for the project. Life on a Dry has shown the viability of anaerobically digesting the waste of a purifying plant for wastewater. We have also taken part in the H2020 project. We are in the second year of the project at the moment, and our function in this project has been to design and build the pilot methanization project that is being used for the project, plant that is being used for the project. The goal of this project is to show the viability of the use of digested in the urban solid waste, to use it as a to feed larvae of insects and to generate protein. We are also conducting a project which is Power Digest. We are exploiting a system of treatment of the digested of the plants of biogas that has been built by Inderen. In this project, we are trying to treat and attach value to the digested of a biogas plant in its the different fractions, solid and liquid, to be used, among other uses, as organic fertilizer. After listing these projects, I'm going to present to you our experience in the ammonia trapping project. The Live Ammonia Trapping Project intends to capture the ammonia in the air to be used as a fertilizer. We are consortium partners in this project and have been in charge of designing and building the two pilot plants to capture ammonia for gases and for liquid. We have also worked with the maintenance and transportation of the pilot plants to the different scenarios and locations where the activities have been developed. In the case of the pilot plant for liquids, initially we set up this in the Porcil, in Guardo. When the experience in Guardo finished, the pilot plant was dismantled and it was taken to Juzgado, where it was installed and set up again, and it started functioning, and this lasted until May, when after the end of the experience, we moved on. We took this to Valencia to carry out maintenance work and repairing work. In terms of the prototype of gases, Initially, we installed and set up in Guardo in the pig farm of the Portrel. When the experience in Guardo finished in April 2019, we dismantled the pilot plant and we took it to the egg producing plant, and where it was installed, and the experience was conducted there, and this was the end of our participation in the project. Our experience in this project has been enriching. It has enabled us to work with a great team of professionals aware of the problems caused by nitrogen pollution. We have worked hand in hand with all the partners to solve the problems of the nitrogen excess in the environment caused by livestock sector and agriculture. This has helped us to see the need to have efficient treatment systems with exploitation costs that are affordable, that enable farms to have a smaller impact when it comes to developing their activity, reaching therefore a better integration in the environment where the livestock activity is developed. In our case, one of the most complex stages of the project was to design the two plants. We were basing our work in a laboratory model, which was used with small volumes, not much more than a liter. So we need to scale this up so that we could apply this to much bigger volumes. And we needed to be able to work continuously. We managed to design and build the prototypes, to set them up, and to start functioning with them, to start operating. Once we started operating, there were new problems that we needed to solve. One of the challenges that have been more difficult to solve was the adaptation of the membranes for ammonia trapping. We need to continue making improvements in this regard so that we can ensure that in the future we can develop commercial solutions that are viable both from the economical, from the technical points of view. We have also conducted a lot of trials with the prototypes to improve this aspect. I'm going to explain a little bit some of them. In the gas prototype at the laboratory scale, we were working with small recipients with a moisture saturated environment. In the pilot plant, what we did was to recirculate through the membranes a number of environmental air, which is normally quite dry. We detected that there were leaks and that this needed to be solved. Therefore, we installed a humectation system that would apply moisture to the air and then modify the process. The main problem that we had with the liquid prototype was the leaks of acid solution due to small holes in the membrane. The laboratory experience was conducted with a very low solution, but the plant worked with a higher pressures than in the laboratory. This meant that the membrane that was developed and tested in the lab, once in the pilot plant, had offered a worse behavior. And this, as a solution, tended towards slurry. So we had to redesign the hydraulic system to solve this problem and stop the leaks in the membrane. The vision of Interren, based on this project, is there's a great challenges for the future to continue improving, both in terms of membrane formats and in terms of pre-treatment and post-treatment that are necessary to be able to build an optimal commercial model. Agriculture and livestock sector is very dependent on resources when it comes to producing their products, and it's struggling to be sustainable in the long term. In this context, it's necessary to use resources in a way that we can facilitate the transition towards an activity that is boosted by knowledge and innovation. We have a firm commitment with technology and the environment. We think that recovering or making use of digestates and slurries is not an absolute need, not only to recover a valuable product, but also to make sure that effluents are used appropriately instead of ending up in the environment. And therefore, we will be able to ensure sustainability and avoid pollution. We are firmly committed to developing technologies and to treat and recover nutrients. in this type of waste flows. Apart from this project, we are also taking part in other calls, which are complementary to this type of technology, with the goal of achieving an integrated solution for recovering these subproducts which have a high added value. So we are doing research and trying to improve the technology to improve the ammonia trapping. Once we repaired the liquid pilot plant, we're going to set this up in another plant where we will continue doing research regarding ammonia trapping with the view to improving the system of treatment of liquid effluents with a high content of ammonia, with a goal to bring to the market systems of treatment of slurries and digesters that minimize the impact on the environment. That's all. Thank you very much for your attention. Thank you very much, Ricardo, and thank you for the technical and technological support to make these prototypes possible and to make their development possible. Um, uh, there are questions from the room, from the floor, from the audience. So I would like to encourage the speakers to start having a look at them. Now, we would like to, on behalf of ammonia trapping, say that there are a number of live projects that we have established synergies with, and we would like to give them the opportunity to also be here today and to show us what other approaches to be found in this field of the livestock sector, etc. So now I'm going to hand over the floor to an expert who is Augusto Martí Blasi. He's a researcher at the Institute of Agri-Food Research and Technology. He's an expert in international projects. He's going to introduce us to the Life Mega project about smart computing system to monitor and abate the indoor concentrations of ammonia, methane, and PM in pig farms. So, August, you have 15 minutes. You have the floor. Thank you.
Good morning. Well, as Raúl has said, I am Augusto Bonmatí, a researcher in IRTA, a research institute in Tarragona. And well, I will now try and share my screen so that you can see my slides, and there you go, it's ready. So the title in English is Smart Computing System to Monitor and Abate the Indoor Concentrations of Ammonia, Methane, and PM in Pig Farms. This is a project that's that takes place in Italy and Spain. Its budget is slightly below 2 million euros. It was started in October last year, and it will come to an end in September, at the end of September 2022. You see a question mark there because obviously with all these issues around the pandemic, the project is slightly delayed. We are more or less, we have a 9-month delay. And so, well, I'll try and explain to you at least what we wanted to do in the project, although not everything has been achieved. The coordinator is UNIMI, the University of Studies in Milan, and the associate beneficiaries, you see them in the slide, IRTA, my research institute, and two technology testers. As the project, as the title says, the main goal is to implement a microclimatic equipment that can continuously monitor ammonia, methane, and PM concentration levels as well as VOC levels in farms. The control device will be the one to capture and activate emission control systems. What are the emission control systems we are going to use or to test? Number one will be a wet scrubber. This is the prototype we've developed in the project by Rota Guido, an Italian company. And then we also have a dry scrubber, which is a commercial equipment that we're analyzing two different companies to see the one we'll use. The prototypes will be tested in two types of farms, a fattening farm and a weaning You see the more or less the way this will work. In most of the farms in Italy will be fattening farms. We will have the dry and wet scrubbers there. And the farmers in Catalonia will be farrowing breeding farms. The scheme in the graph as well explaining all these. Key actions. Action number one is to install emission control systems. This is the situation we should be at now. They should be installed by now, but we're a little bit delayed. The first equipment in Italy was installed just last week. Action number two will be monitoring and controlling emissions. Number three, optimizing the wet scrubber by microclimatic control means. And also this project, apart from controlling emissions and testing emission levels, we will also take into account other animal welfare indicators. As the previous speakers have mentioned, ammonia and other compound presence in farms also have an impact in animals. So we will also test and take that into account. And then we will also look at life cycle activities, etc. What are the impacts we expect to achieve? This is something typically required by live projects. Well, with this wet scrubber prototype and emission control system, the idea is that we will be able to reduce 48% for ammonia levels, PM10 70%, and for PM 2.5 about 60%. The table below explains the same, but expressed in terms of heads per year. So this is what we expect to achieve. When we come to the final project results, we'll see what we achieve, what we actually achieve. So we are now at a position where we are installing the emission control system. It's a total of 4 farms, 2 fattening farms in Italy, 2 breeding or farrowing farms in Spain. The prototypes will be in place for 9 months in each farm. And well, the characteristics of the farms we're looking for is basically farms with very similar units this is something that we've tried to analyze and that we've chosen based on the farms we have in Catalonia. And these are the areas where you will see the reference, the dry and the wet areas. Based on, or in each of these units, we will measure emissions and also the animal welfare indicators I referred to before. This is the scheme for the wet scrubber, the one we're developing in the project that will be placed outside the farm, outside the units. There will be an inlet and an outlet, so that the idea is that we can recirculate the air, which is very important because we cannot interfere in refrigeration, heating system for the farm, etc. Something that's particularly important in depending on, well, the summer and in the winter, depending on the temperature conditions. This picture was taken last week. You see the installation in the Italian farm with the scrubber and the inlet conditions. And in the case of the farms in Catalonia, we will start with the installation next week. Monday, Tuesday, we'll receive the team and the equipment, and it will be assembled more or less on Thursday. We are subject to some limitations because of, well, travel restrictions, current travel restrictions, so we will be the ones in charge of assembling these. No members from NUVAP and other companies can come to Spain. So, well, we hope we'll be able to assemble everything without any huge problems. Action number 2 involves monitoring emissions and everything about the control system. And here NUVAP has developed an online measurement equipment to analyze ammonia, methane, and PMs. And this is also the device that should control the wet and dry scrubbers. This will be installed soon as well, next week. We've already received the equipment at our facilities, and well, everything should be ready by next week. One of the ideas of the project was to periodically measure emissions within the farms and at emission points in the farms to control, on the one hand, that the system works and operates properly, to make a comparison amongst the three units, and also to assess the life cycle, which is something mandatory for life projects. I also referred to the importance we attach to animal welfare indicators. We've split this up into three main groups: productivity, health, clinical measures, and carcass condemnations. I'm going to try and explain to you what this all means. We have a specific group in IRTA working on this. And well, as for performance, in weaning farms, we look at initial and final body weight, and in fattening farms, we look at carcass weights, if it's possible in Italy, and then body conditions as well. This is, well, in the slide, you can see more or less the condition score of swine and the way we measure all this. As for health, clinical measures, well, basically, this is based on the air quality protocol definitions. And we at the IRTA will analyze the Catalonial farms, and we will give training to the staff from the Italian farms if we're allowed to travel there. We'll see. And just to show you what these animal welfare indicators are all about, well, number one is what I said before about body condition. Then in some of the housing units, we look at, for example, absence of manure at body level. A good indicator of good health is everything that has to do with tail biting, cough, sneezing, hard breathing, etc. And then everything that has to do with social behavior as well. This is based on visits, and well, experienced people know more about this. Just to give you an example about, for example, lack of manure in the body. How is this assessed? If the pig is typically clean, it's given at 0. If it's a little bit dirty, number 1. If it's very dirty, we give a score of 2. Then, well, this is just to the indicators of good housing. And then finally, there's also one point that has to do with the carcass condemnation. This is only for fattening farms, and this has to do with slaughterhouse conditions. They always require you to, well, analyze parameters such as injuries, wounds, etc. And what would be interesting to analyze here, I don't know if it will be possible because access to slaughterhouses is very limited, but it would be very interesting to analyze tail biting conditions, which is one of the most important indicators at slaughterhouse levels. The final action we're involved with, life cycle assessment. Well, we will use as reference scenario the fattening farm in Italy and the weaning farms in Spain. They will all have inventories for life quality assessment, and we will well, look at basically scenario number 1 will be fattening farm with wet scrubber, scenario 2 fattening farm with dry scrubber, and well, you see them in the slide. And well, this is all I can tell you so far because that's all the information we have up to this point. This is our website where you can find more information about the project, more details. And well, I kindly invite you all to have a look at that website and to look at what we do during the next few years. The information will be there. I hope that always published on time. And that was all from me. Thank you very much for your attention. And if you have any question, or I think it's going to be at the end of the session. Yes, there was 12 or quarter past 12. Yes, August, after the 2 presentations that we will now listen to about some other live projects, we will have all the questions and answers. So thank you very much, August. I'm now going to give the floor to a presenter that will tell us about another live project, clean air farming. They will explain to us ammonia and methane emission reduction systems to improve agriculture. This speech will be in English, and you can use the interpretation button to access it. So whenever you want to, Christine Hellerstrom, you have the floor. She's the project manager, and she is a representative from Deutsche Umwelt. I think it's going to be easily understood in environmental action in Germany. So whenever you want to, Christine, you have the floor.
Hello, thank you very much. Good morning, everyone, or good day. Saludos desde Alemania, Baviera. Yes, I'm very happy to be able to contribute to this workshop. I am a project manager and trained environmental engineer working for Environmental Action Germany, which is an environmental and consumer protection organization based in Berlin and at Lake Constance in the south of Germany. I've been coordinating this project since August 2018. We have another 1.5 years to go, hopefully, and we are consisting of 4 partners in 3 countries. We're based in Brussels, the Environmental EB, European Environmental Bureau, and France Nature Environnement in Paris is also on board. And I'd like to quickly show you what our approach is. So we are addressing both ammonia and methane emissions because obviously they result from very similar sources. Ammonia is coming over 90% from agricultural activities, methane over 50%, with a rising share because methane emissions in Europe are decreasing slowly, but the share of agricultural emissions is rising. So we need to address them, and both emissions affect air quality as well as climate. Many people don't know that methane is a precursor for ground level ozone, and ground level ozone is a problem which will be more urgent in the future because temperatures are rising. There will be more ozone peaks. That's why we need to address all ozone precursor gases. So sometimes Germany claims to be a forerunner or role model in environmental policies. The next time a German person tells you this, please show him this graph. This is not the case, at least for ammonia. We are breaching the NEC targets since 2010. We have more than 20% above the ceiling we are emitting. And our goal is that until 2030, we should reduce our emissions around 1/3. So there is still a lot to do ahead of us. And our approach is to engage different stakeholders. One topic which is sometimes not very much linked to emissions is food waste, because food waste has the potential to reduce emissions when there's around 1/3 of all food is wasted along the supply chain. So what we do is we create public awareness for the topic, and of course we address decision makers in politics to make new regulations, better regulations, for example, to give food away when food is expired in supermarkets. At the moment in Germany, there is a law that the supermarkets are not allowed to pass on the food to charitable organizations or other initiatives. Of course, this could be changed. We see it in Italy, we see it in France, it's working. And that's one hook where we address emissions. The other one are more approachable and direct. So for example, food standards. Food standards define the regulations and the quality criteria with which food is produced, with which farmers work. So we sit together with food standards, explain them the problem of ammonia and methane emissions, and want them to include their criteria in their food standards. Another action are farmers associations, roundtables with farmers associations. So the goal is to have a common position with farmers associations together with environmental organizations to find a solution pathway, how we will reduce emissions. There are different ways, of course, different measures, and we need to come to a conclusion together, in our opinion. Then another action are expert talks with responsible actors of the agricultural education. Of course, the farmers of the future need to know the problem and they need to know the solutions. And we often see that this is not included in the agricultural education nor at universities where agriculture is taught. So we talk with multipliers, we analyze why is this so, and we are developing at the moment best practice videos. We already have one on our homepage where we show that it's possible to reduce emissions yes, but like another person said it today, the information should be approachable, easy to understand, comprehensive. So this is, I think, a hook where we can work on. Then what we are doing in Berlin, environmental action, is that we talk with decision makers about the national air pollution and control programs, because we, as I will explain you further on, see that there are huge gaps in the programs, and there are also many obstacles why measures are not implemented yet. For example, there is the myth that animal welfare and emission reductions are conflicting objectives. We have shown in an expert talk that there are several ways that these two objectives go perfectly together. For example, in a pig fattening sector, you can give the pigs as more space so that they actually have their function areas, and they have their dirt spots, they have their resting spots, and the dirt spots can then be managed very well and cleaned regularly. Another field is, of course, the advocacy work, because we want to strengthen the role of civil society during several legislative procedures. We have to have everyone on board, because otherwise we can make targets and they will be of no interest. So there are several things going on at the moment. We have the NEC, we have the urgency to act, because ammonia emissions have been increased in the EU since 2013, and we have seen that there's a lack of implementation of the NEC directive. The Commission drafted or published an implementation report in June, which says that most member states are not on track with their national emission reduction commitments, and they will fail to set enough ammonia reduction measures. There are more windows of opportunities coming up. You know, the farm to fork strategies, the common agriculture policy. There is also a EU methane strategy expected in October. We want the EU to have binding measures, binding instruments following this methane strategy, so that we don't need to evaluate more. Well, of course, more data is great, but we already have a lot of best practice, and we know that we have to act. And so that you need to really implement binding measures. And there's also the potential review process of the Gothenburg Protocol, where future goals, emission goals, will be set. And I quickly want to talk about the German National Air Pollution Control Program, because this is also the case in other countries. It should be clear that clean air is a basic human need, even though the German authorities have ignored air quality standards for years. That's why we're working on political level to make it better. But our organization is also entitled to bring legal actions under the Environmental Appeals Act. And with the support of our organization Client Earth, we filed a lawsuit against the German government, because we want the German government to finally set up better measures enough measures in the air pollution control program, and to fulfill certain standards. The Commission in the implementation report is supporting our position, and is stating that we have a great risk of not complying with reduction targets. So when we look at our control program, we see that the emission projections lack credibility. So to say, there's often assumed that there are often assumptions that are not realistic, and the emission projections have high uncertainties. Of course, that's natural. Models have uncertainties, but then politics need to have a set of measures that account for those uncertainties in order to compensate for them, in order to make sure that we reach reduction targets. And there are also the obligations in the NEC directive that the NAPCPs need to have specific elements. For example, a timetable for the implementation of measures and the review. And they also have to name the authorities in charge of the measures. Of course, one ministry can write, yes, this measure will take place, but then the other ministry hasn't heard of it and they should be in charge. And we see that kind of, and we need to have we need to have the authorities clear who's in charge. Also, there need to be reasons for any flexibilities and also non-linear trajectories of the emission projections. And there should be a coherence with other politics, for example, with the national energy and climate plans. We would also look at the wider picture, because one part of the truth is that we need to implement the tactical measures fast and urgent and quick, but in the long run, we also need to change our food systems. Meat and dairy from 230,000 cows is wasted in Germany, only in Germany, every year. So the key is less waste, less consumption of dairy and milk products, less production, because we need that in order to reach a Paris Agreement until 2050. If we want a climate neutral continent, and I'm saying this on the day when there's a climate strike today by Fridays for Future, at least here in Germany, then we need to have a change there, and we need to produce better food with higher added value to sustain the living of the farmers. And the development what we see right now in the whole of Europe is not sustainable. If you want more information, please have a look at our website. Thank you very much for listening. If you have any questions, please don't hesitate to contact me.
Thank you, Christina. Please wait with us in order to participate in the round table with the questions. Thank you very much. Y ahora tenemos el último proyecto.
Now we're going to move on to the next project, which is the Life Prepare project, which is located in the Po River Valley regions, and these are committed to the policies of air. They're engaged in policies of air. So Katia Raffaele is going to present this project, and also Chiara Massoni, who belong to the regional government of Emilia-Romagna, the Emilia-Romagna region in northern Italy. So you have the floor. Thank you very much.
Morning, everybody. My name is Katia Raffaele. I'm the project manager of the project Life Prepare. I'm speaking also on behalf of Mr. Matteo Balboni, who is the director of the pillar agriculture inside the project, and of Ms. Chiara Mazzoni. Project Prepare has been financed by European Commission in 2017 in order to improve air quality in the Po Valley, one of the most complex areas in Europe for air quality due to the orographic characteristics of the basin and, as a consequence, the meteoclimate conditions that influence the dispersion of pollutants in the atmosphere. As a matter of fact, all the regions have adopted their air quality regional plans, but common actions are necessary. And in fact, since 2005, the regions and environmental agencies are cooperating in the development and use of common tools. And in 2013 and 2017, two important agreements have been signed with the national government. LFP Prepare has started in 2017 and will last till 2024. It involves 18 partners with a budget of 17 million euro.
Each involves an area of 135,000 square kilometers in Italy and Slovenia, and 28 million of people, and involves 7 regional air quality plans. We have identified inside the project some areas that we call thematic pillars, and these are the main sectors that influence air quality in the Po Valley, and are agriculture, of course, biomass, transport, energy efficiency, air quality evaluation and monitoring, and last but not least, communication and governance as cross-sectoral tools. Finally, the complementary actions. As you know, each integrated project has to mobilize an amount of complementary funds, and in fact in Prepare we can see something like 950 million euro of actions that are synergic to the actions implemented by the project Prepare itself. Now, my colleague Chiara Mazzoni will describe the actions of the project more related to agriculture. Thank you very much.
Good morning. Now we will describe the 2 concrete actions, C4 and C5, of the pillar agriculture of the Prepare project. Action C4, promoting an ammonia low emission application of fertilizers based on urea in agriculture. Ammonia emissions come mostly from the activities of the agricultural sector and contribute significantly to the formation of secondary particles. The application of fertilizers containing urea may cause emissions of ammonia from urea degradation prior to absorption by crops. It is therefore important to identify the best techniques to limit these emissions. The project aims at identifying the best application techniques of urea-based fertilizers, which often cause ammonia emissions deriving from urea degradation before absorption by crops, and at verifying, also through field-based analysis, the opportunity of replacing urea with other nitrogen fertilizers or with organic substances, with assessment of the environmental costs and benefits associated. The project aims at individuation of the techniques currently used for fertilizers application, of the quantities used, of the farmers involved, and the realization of case studies. The project aims at the estimation through tests of the generated impact in terms of emissions reduction. The project aims at specific analysis for the identification of the best application techniques with respect to the adopted cropping system, or the possibility to identify technological applications to reduce chemical fertilizers or to advantage of natural fertilizers, for example, livestock manure, or to other nitrogen fertilizers with a lower nitrogen release into air and water. The project aims at evaluation of the costs and of the replicability of the techniques in the area of the Po Basin, with involvement also of producers of fertilizers and farmers' representatives. The outputs of this action, reported in a position paper, will be used as guidelines to direct the allocation of the complementary funds of rural development programs during next European programming period. It will be a position paper, a report, on agrarian system perspectives with identification of the good practices to reduce ammonia emissions from chemical fertilizers, including economically sustainable low-emission fertilizers applications, evaluation of the amount of ammonia emissions avoidable, and description of several possible scenarios. Action C5, implementation of a common model for evaluation of gaseous emissions and odor resulting from intensive rearing of cattle, pigs, and poultry. It is estimated a contribution of over 95% from the agriculture sector to ammonia emissions in the Po Valley. As a matter of fact, emissions of ammonia are one of the most important precursors of particulate matter 10, and NEC directive establishes a limit for national emissions of such pollutant. It can be also important to consider that through the best available techniques application, it is possible to fulfill a relevant reduction of the emissions that can vary basing on the animal category and on specific conditions. Example, up to 50% of emissions reduction for pig farms. The action consists in the elaboration of a common model for the evaluation of gaseous emissions, ammonia, nitrous oxide, methane, and carbon dioxide, odor emissions, and potential release of nitrogen compounds in water deriving from cattle, pigs, and poultry intensive farming activities, with the whole farm approach, after a wide examination of the existing models applied for the same purpose. The model is applicable to the single farms and has been developed through the implementation of a dataset shared among the regions of the Po Basin. It can be tailored on different farm typologies, on different animal categories, and on local characteristics. It evaluates the impact of breeding activities on air quality and based its logic on the following recognized principles. First of all, a whole farm approach to estimate the overall gaseous and odor emissions of the livestock farm and in general of the whole agricultural farm, which are produced during the various stages of production and management: nutrition, housing, storage, manure, treatment and spreading, crop management, taking into consideration the interaction between the benefits obtained in a given phase of the breeding cycle and the impacts of the subsequent phases. The optimization of cattle feeding, manure management and spreading, and crop management practices should generate reduction of the environmental impact. Another important principle is to consider all the environmental components and the interaction between water, soil, air matrices. Best practices aimed at reducing nitrogen particulation into groundwater might not be so positive with regard to atmospheric emissions and vice versa. The final version of the model will be composed of two interrelated modules. The first module will be qualitative, with the aim of evaluation the environmental sustainability of the livestock farm. The quality evaluation will consist in awarding each farm a score that shall estimate the environmental impact of the farm from a qualitative point of view and give indications on the improvement possibilities. The second module is quantitative and will estimate the gaseous and odor emissions coming from the different phases of production and management of the farm, also in consequence of the best available techniques application, including those concerning agrometeorology and crops management, and so to evaluate their impacts on air, water, and soil. The action will also set up a system for providing assistance to farmers for choosing the best application techniques with respect to the meteorological and soil conditions in order to minimize ammonia emissions in the atmosphere. Through best available techniques application, it is possible a relevant reduction of the emissions that can vary basing on the animal category and on specific condition. With the model application, we expect to achieve relevant reduction of ammonia emissions from farms, from all the phases of housing, manure storage, treatment, and spreading, and a simultaneous reduction of greenhouse gases emissions. Finally, a first version of the model for poultry and pigs is already online about a year ago and is used for the IED permit update process. It allows to estimate the emissions after the best available techniques selection adopted in the company, as defined in the best available techniques conclusions. Thanks for your attention and goodbye.
Thank you, Chiara. It's a pleasure to count on you in this seminar. Muchas gracias, Chiara.
Thank you very much, Chiara, as I was saying, and your colleagues for this presentation, Katia and Chiara. We are now going to move on to the final round of discussions, the questions and answers round. So I would like to ask all of the panelists to please, if you can, switch on your cameras and, well, at least your microphones, so that we can, well, move on to these questions and answers. So let me start with the questions that we've received so far. The organization has compiled them in a document, in a sort of slide presentation, so to speak, and we will start seeing them soon. So the idea is that you can read them in English and in Spanish. I'm going to share my screen now so that you can see the slide presentation and so that you can, well, have them there in view.
Okay, there we go. Screen number 2, share screen number 2. I hope you're seeing it now. We have compiled questions on that document. So firstly, there's a question for Jesus Siria. Apparently, the question reads, is this technology profitable financially, of course, on free-range egg farms like yours, where half the year the facilities have all your walls open? Does the profitability comes through other aspects like animal well-being, meeting the regulations, etc.? Okay, thank you for that question. Well, more often than not, the regulations that we need to comply with cannot be actually applied to the final price of our product, and we need to be responsible for this. So this is like going a step further. This is like a person who, you see, like it's like a vicious circle in a way. If you might be eating a egg just alternatively produced because you have a subjective perception of the product due to the issue of animal welfare. In principle, well, I don't know if it could be cost effective in terms of setting these up. Once a project like this has offered good solutions, then we need to start producing things, you see, generally, or a lot of these products available for many livestock races. So in this case, maybe we can, with minimum ventilation, and perform this type of process with this type of installation, with type of premises. So what we are doing is to extract ammonia and then recirculate air so that the air that's coming in has a certain temperature, but without ammonia and so on and so forth. But in principle, we can say that it should be viable, because if we are demanded to do this by law, we need to do it. So maybe if the cost is high, we should have some sort of financial support to set up this type of system, to install it. And once we start improving this type of installations, then this might have an impact on the consumer in terms of price. When we talk about X, it's going to be some euro cents. So if we are to install systems that are going to improve the environment, maybe we can reach that balance. But at the moment, I'm not sure we are ready to do it. We're not ready to pay more money for a dozen eggs compared to a free-range chicken, and the price of eggs coming from free-range chicken. But we're starting to see that, well, consumption is increasing, and that these prices might have a final impact on the consumer. So a product like this might end up being applicable in terms of prices, and it might be economically viable when it comes to starting doing it like this in small farms for free-range chicken. Okay, thank you for the question. It seems clear that just like it happens with all technologies, the financial analysis has to be considered, of course, until we reach a sufficient degree of development. Now, it's well, interesting to see that we can conduct this type of chemical magic. So maybe Mercedes can tell us a little bit more about it. We have a question about the role of sulfuric acid to get that with ammonium sulfate, and how do you get this concentration? Is it solid? Is it liquid? It's a liquid solution. In my presentation, I showed you how the conductivity varied. You know, when you enrich the solution with ammonium sulfate, you get the less of the other element. So you get different concentrations, and this is why you get different results. So when you enrich the solution, the pH level increases. We always maintain a pH below 2, so that capture is maximum, and then we add more sulfuric acid so that this pH does not increase. But in the final stage, we would not be correcting the pH, and we would leave for it to go up so that we get a final product which has a neutral pH. So we wouldn't be needing to separate it in any way. It would be a ammonium sulfate solution of the concentration that we obtain at the end of the process. Thank you very much. Now there's a question for Alberto from our pig farm. To make a cost-benefit analysis of the project, you had the experience of the pilot project, and probably you have in mind already how to improve it or how to make it viable from the financial point of view. So can you tell us a little bit about it? Can you elaborate upon this a little bit? Can you hear me now? Yes, we can hear you perfectly. Yes, good morning. We're talking about a prototype stage, but it is clear to us that if we want to know the real cost, we maybe need to talk about, something different that the initial stages, or we can use this as a basis in any case. If we're talking about costs based on which the management of slurry in a farm is very variable, it can vary 2 to 3 euros. And if we are using a prototype, this can increase by 10 to 20%. This doesn't imply that we are not going to have benefits, because there are molecules such as ammonium sulfate, and there is something that is very important, as Jesus already said, is that we need to be able to work in better environmental conditions and enable a much more precise and accurate application, and to obtain a and a proper application is that we can decrease the level of nitrogen in slurry, and therefore the management is going to be easier. This is an inception stage in any case, but I think that when we consolidate this, then the cost is going to go down. And on the other hand, I think that the important thing here is not the cost, but to be able to conduct a proper environmental um, management in the various livestock producing areas in question. I would like to introduce a question from my point of view. We have seen other systems that trap ammonia also, such as the one that's been suggested by the August Bomadi Life Project. So potentially the use of chlorine in modular way has the same goal to trap nitrogen. So depending on the experience that you've had so far in terms of module costs and cubic meters that have been treated, could you give us a vision about an outline about costs in terms of the system that you are suggesting, that you are proposing, that you're bringing to the table? August, please. Are you asking me about costs? Well, it's difficult to say right now. I'd need to check with the company who designed this. It's one of the goals of the project in the case to verify whether by using this module, we need to use different compartments or work with different compartments with this. So we are at the stage of proof of concept, the extent to which we can change levels of ammonia and other gases, but I'm going to write it down so that maybe in the future I can answer this question. Yes, of course, maybe we can know what is the treatment capacity per time unit and what is the impact that this can have. I think Maricruz is ready now, because I think this question might be for her also. Odon, who was one of the speakers yesterday, is saying that one of the main reasons of the diminishment of the performance of anaerobic digestion is the presence of ammonia in the slurry. So we get the question that maybe tackling ammonia trapping, not only based on digestate when the anaerobic digestion has taken place, but during the process itself might be an option. So maybe could you tell us a little bit about that, Maricruz? Yes, we've got options that we've conducted with the membrane inside the digesters. These are studies that are going to be published soon as a part of a PhD thesis that has been conducted by a PhD dissertation by a colleague of ours. And we've seen that as an average, we managed to increase the production of biogas by 17%. And additionally, that biogas is richer in methane. We have an average of a richness higher in the biogas would have a 11% percentage higher of methane than the control samples. So this improves the process not only for the richness of this biogas, not only for the production of biogas. So it does improve the process, apparently, yes. Okay, Maricruz and Mercedes is another question for you. Apparently, after listening to the representative of Inderen speaking, one of our participants has the following question. Can we conclude that this technology might be commercialized in an affordable way to companies? Is there any timeline provision for this? Is there any company willing to do this in Spain or the US? When are we going to have a company who's going to be able to provide this type of service? Technology seems to be something that people are liking, so people are starting to think about buying this already. Okay, I'm going to answer first, and then maybe Mercedes can add something. This is just like any other technological development. There are stages. In this project, we've gone from a laboratory-based stage where all the experiences were being developed at a small scale in a laboratory environment. So with this project, we've moved on to a different stage in terms of development. So, and we have tested a prototype that operates with more than 1 and 2 liters of slurry. Therefore, everything is going step by step. Technology is being developed gradually, so we need time to develop this. So in this case, we think that there are a lot of improvements that can be made. This is improvable. This can be done, but I think that the technology is mature enough to enter the commercial stage. It's going to take a while, but we think that it is mature enough to be marketed, this technology. And it gives a response in terms of trapping ammonia, and therefore now it's about you see, now it's about investing money to develop this commercially. Yes, at the end of the day, it all comes down to money, doesn't it? It's about investing in order to develop this prototype and to introduce all the improvements that we have identified throughout these 4 years, after all the experiments and all the testing that we have conducted. The technology, if we do that, I mean, the sooner we do this, the sooner we're going to have it available in the market. Okay, at this point, we could ask Christine from the Life Clean Earth Farming Project, what is the situation of this type of project in terms of evolution of ammonia trapping projects in Germany? What's the situation in Germany?
What is the situation about the implementation of the
So you mean in general with regard to ammonia emission or uptake of technologies?
Well, both.
I couldn't hear you. Sorry, couldn't hear that.
No, we are.
Yes, both.
Both. Okay,
Both.
so I'd say that we're at the very beginning of implementing any new technology. I haven't seen or heard of any pilot projects. I think there is potential. Yes, well, the discussion about that, the hopes are great that soil acidification, like it is used in Denmark a lot, will be implemented on a wider range. But research and development, I think there will be happening much more. And at the moment, the skeptics is very big, and we haven't seen many. But we want to portray them, and this is also a possibility and an invitation that we could portray a pilot project and other projects around Europe and translate it to German, see if it would be feasible in Germany, and so on, to see if it's transferable.
Perfect, Christine. Es cierto, la verdad que ahora
That's
mismo.
great, Christine. Thank you very much. Well, it's true. Right now, we could say that there is a very powerful trend throughout the agricultural world in terms of designing livestock housings, integrating not only animal welfare, because animals are going to be better if there is no ammonia, but also the trapping of these gases in order to foster the circular economy. Now I would like to hand over the floor to Matteo Baldoni from the Life Prepare project, because he's working in the Po Valley region, which is, there's a lot of livestock production there, intensive livestock production, so they're experts in managing the slurries and the manure. So I would like to ask him what's the situation and the evolution in the Po Valley in northern Italy of all these different proposals, whether they are viable, whether they are being developed. And so please, Matteo, can you elaborate a little bit upon this?
Okay, I hope I understand the question, because I don't hear the traduction. But in the Po Valley, there is a high pressure on the implementation of these technologies, because it is, as Katia Raffaelli told in the presentation, a very complicated area for air pollution. The situation is getting better, but some criticities still remains. And in particular, there are many studies that are evaluating the contribution of each sectors, and some studies now, many studies are now under construction, also considering the lockdown experience that allows to have some data in the early months of this year. One driver for implementation of these technologies is the EAD directive, the Industrial Emission Directive. In Italy, the EAD permits are very strong, and the evaluation are very deep. So there is the way to evaluate for the installation under this directive, which are the best available techniques for every single installation. And if it is not possible to adopt one technique in a certain phase of the installation, like it's not possible, for example, to cover the storage, it is possible to find equivalent techniques in other phases. For example, the diet of the animals, the housing systems, or the spreading techniques, the manure spreading techniques. Application. Another, and it is important, but it is important also in adding to the regulatory politics, so like authorization and laws and environmental laws, to use the EU funds to give the possibility to a better implementation of the techniques, and to increase the economical feasibility of the application of these techniques. So it is important to act on both these aspects, and LIFE project, with the model that we have, one of the aim of this model that we are constructing is to give a a unique instrument of evaluation, both for both for better construct the permits and to better construct the funding bonds, the funding politics, so that the two things can go together.
Okay, thank you, Matteo. So we are on working right now in all this stuff. Okay. Gracias, Matteo. Tenemos dos preguntas.
Thank you, Matteo. We have two questions that I think we can stick together into one. They tell us about technical issues of that wonderful membrane we've seen, that membrane that can capture airs and be immersed into dirty liquids. And well, somebody who's worked in this field is asking us whether any kind of biofilm can appear at membrane surface level, and whether those membranes get somehow dirty. I mean, obviously, Maricruz, you've submerged them into slurry. So can you tell us about fouling? And well, we've been working with the same membranes for 2 years, so they do get dirty. They do get sort of black, dark because of these slurry compounds, but no biofilm appears. We haven't seen it so far. Can you explain what a biofilm is? A biofilm is, so to speak, a layer of bacteria and organic compounds that adhere to the external membrane surface, creating an outer film that may impede an adequate operation of the membrane. But in our case, we've seen that performance yield is not reduced or affected. From the initial stages until 2 years later, working with the same membranes, we had to change some parts, some percentage of the membranes because we had some dripping problems. But in some panels, no membrane change has been required. They've been operating for 2 years consecutively and no biofilm has appeared. Performance level is the same from the very beginning until the end of the work we've conducted. Great. There's another question that I think can be addressed, well, to the panel as a whole, maybe Auguste or Christine or any of you actually can solve a doubt that's posed here, which is how can we efficiently measure gas emissions within the housing, not only ammonia, but other greenhouse gases? What experience do you have with measuring those gases? That could be of help to us. So Auguste or Christine, perhaps? Shall I start then? Okay. To measure continuously, there are some sensors. And in fact, that's what NUVAP does. They develop an online sensor for methane, ammonia, PMs, volatile compounds. And what we do is we have a test. What we actually do, we take a sample of gas in a pump, we recover it in an airtight container, and then we assess it in the lab. This is offline. So the sensor measurements are contrasted with the theoretically more reliable measurements obtained in the lab. And this is basically what we're doing. Many sensors are being developed for online measurements, photo, acoustic, photo, laser. Many things are being improved in this regard. The problem with online measurements is that there are many interferences with compounds. I don't know if anybody else has something to add. Christina, perhaps? Okay, what I can contribute about this point is that there's also a network working in this field. It's called Remedia. It is working in the field of mitigating greenhouse gas impact. And well, what Auguste was saying is totally true. It is still very difficult to adequately monitor gases in the housing systems. Maybe indirectly it's easily done. The basic idea behind these research groups is to perhaps develop indirect measures that may allow them to, well, after monitoring farms on a pilot stage, well, to optimize their parameters. This is very much in line with the life philosophy, actually. Raúl, if I can add something, I'd like with regard to what you asked about biofilms before, we really believe it's not that membranes are wonderful. I mean, they are, obviously, but they are immersed in a very corrosive liquid. So I wanted to add that we think no biofilm is created because we put no pressure on the membrane. And this is something we didn't mention before. Ammonia diffusion is, or dissemination is passive. It's passive entry. We don't exert any pressure on the membrane. And maybe that is the reason why no biofilm has appeared on the membrane. So it's just something I wanted to clarify. Yes, thank you very much. And I have another specific doubt, which is, what is the experience of networking, working together with others, learning from other experiences and experiments? So what's your experience from that? We have Mateo, Auguste, Mercedes, Christine. Many of you are involved in networking. You work in 4 life projects with a sort of common thread or common element. What is your feeling about this? Do you think it's been positive for you to make these contacts with other similar projects, or you do not identify them as rivals, as a competition, don't you? It's you see them more as a synergy. That's my position, what I think, but I'd like to know your position about that. Mateo, please.
Yes, I agree. Absolutely, it's a great synergy, I think. For example, and it is very interesting to be here and to know about this project and about other projects related to this argument. For example, if in our model, it is important for our model that I mentioned before to remain updated. Also with now it contains the best available techniques described in the BAT conclusions. But these techniques will evolve. We hope, in time, and we hope that some techniques now that are now in studying, like these techniques of the membrane, and like other projects, like the one of the other life projects coordinated by University of Milan. We hope that these techniques will grow and will become BAT, so best available techniques. And so for our these techniques will be included in our model. And this is only an example of how the knowledge of the projects that are ongoing can be useful each other. And so we are in contact with several projects like this, and I think it's very important to do networking.
Okay, Christine, your thoughts about this?
Yes, I think it's very essential, and it's also the essence, I think, of Europe and of networking, that we exchange the knowledge here, because we are moving in a field which is not very prone to new developments and innovations that maybe in other sectors, people working there are more open. So we have a challenge with difficult tasks coming up, but the exchange is very important. And yes, when I talk to people, then even when they come together from Germany, from different regions, it's so much different knowledge available there, and then I can contribute with the knowledge that I gained here, and it's super useful, I'd say.
Perfect. August, tú con tu amplia experiencia de proyectos, ¿cómo lo ves?
You with your experience, Auguste, in so many... I'm just going to repeat what the others have said. You can say the opposite if you want to. Now, I'm trying to think about something I can say, not to repeat what the previous speakers have said, but I can't. I mean, I think it's really relevant, particularly with this pandemic and what it's involved. I think this is the a great time for exchanging opinions and networking. Some time ago, um, face-to-face meetings, seminars, all these meetings were really important. Now we can't do it. Well, we've had to find other strategies and solutions to exchange that knowledge. We're limited, obviously, due to the current pandemics, but well, we have to do as much as we can. This initiative today, for example, is really relevant. We're doing many things online, but obviously the Commission wants us to relate to each other and to use the knowledge acquired from other projects, not to repeat what others are doing. So just to share a free thought, so to speak, it's somehow paradoxical, so to speak, that when preparing a project, you meet others in athletic ways where you're competing, but then if you are given this project, it's as if you were in the podium and you can actually compete and share with them. Competition or sharing of resources, well, it's similar. I think we can close this session now. Thank you very much. I think perhaps I'm going to give the floor to the coordinators of the ammonia trapping project just to close this discussion. Yes, thank you very much. I'd like to say that we've actually been involved in a lot of networking with other projects. Particularly, Maricruz and myself traveled all throughout the Mediterranean coast in Spain, Valencia and Murcia, because we were contacted by other live projects that were having problems when obtaining good yield values with other prototypes, precisely because of ammonia presence. That led to a synergy between their projects and our projects to actually make their project work better. And it worked better by informing them about our membrane ammonia capturing system. We've been involved in many other projects as well, some exchanges in other member states. In Bratislava, for example, there was a live seminar, and we contacted other live projects that could have similarities with ours and with which we could establish synergies. So it's not only through the ESMES website, but also attending face-to-face events that we actually created many synergies. And after these, we've frequently received emails showing their interest in our technology to actually use it as a complement to their own technologies. Maricruz? Yes, I would like to thank all the participants, the panelists, all the speakers. Raul, obviously, you've been an excellent moderator. And well, I think that during these 2 days, both yesterday and today, we have tried to, and we've managed to make the voices of many stakeholders heard, representing the farming industry throughout Europe. We've had speakers more focused on regulatory policymaking aspects, yesterday mainly. Today, we focus more on research, what we're doing, what our colleagues from other parts of Europe are doing. And well, I think that these 2 days of seminar have been very, very interesting, very successful and fruitful, I think. And I hope for those, well, for the panelists and for the members of the audience. So thank you very much to my colleagues, to the panelists. Thank you, Raul, for your contribution. Really, you've been a wonderful, very dynamic moderator. And well, I'd also like to thank our colleagues from other projects and the policy makers as well, those from the regulatory authorities and so on. So thank you all for attending this seminar, and we'll hope there will be another one to see you again. Okay, thank you very much, everybody. It's true that all the panelists and their contributions have been very complementary and an add-on to each other. And I think that, well, this is being recorded, by the way, and I hope that this will be available within our website soon. Just to finish, I'm gonna give the floor to Mr. Carlos Fernando Cabezas Pascual. He is the manager of the Fundación General Universidad de Valladolid, and he's going to make a final intervention live. So Carlos Fernando is the managing director of the General Foundation of the University of Valladolid. And well, that foundation has a very, very relevant team that has helped this project move forward. And well, so I'd like to thank them all. I'd like to thank all the organizers of this seminar as well at a technical level, all the members of staff working with Mercedes and Maricruz, and all the members representing the foundation, particularly Rocío, the one I've been mostly spoken with. So thank you very much. We'd like to thank you all for participating, and I'm going to give the floor to Carlos Fernando Cabeza Pascual.
Thank you very much, Raúl, for your kind introduction, and I am going to ask for your permission to read some words that I have prepared for the closing session of this workshop, this technical workshop. And I apologize if some of the things that I'm going to say are going to be repetitions of what have been said, or the things that have been said by the rector already, or by the various speakers taking the floor throughout these 2 days. So just to close these sessions, I would like to convey to all of you my satisfaction for the success of these workshops, and I would like to also thank all the speakers who have taken part in this workshop and have shared their knowledge and their points of view, the different points of view on an issue which is very important nowadays, which is emissions, environmental emissions to the environment. I would also like to thank the participation of authorities, experts, business people, representatives of different organizations, and the coordinators of projects who have brought to the table their point of view and have given us very important keys to tackle a problem as pressing as the emissions problem, in particular ammonia emissions. Of course, all of these is included in SDG number 13, Action for the Climate. So the General Foundation of the University of Valladolid has coordinated throughout the last 4 years the Live Ammonia project that has been dealt with today intensively by Mercedes, by everybody, and we are committed to projects that bring us closer to the sustainability goals that are set up by the European Union. So for the administration and coordination of this type of projects at their foundation, we put our experience and knowledge at the service of workers of the University of Valladolid and the partners of these projects, just to get them rid them of the administrative and bureaucratic burden, the paperwork burden that these projects involve, so that they can focus on what they do best, to do research and to contribute to the social progress. Therefore, in the case of this project, the pathway has been long throughout these 4 years, and the foundation has coordinated a number of partners, and we have the goal to develop and bring to the market an innovative technology that will contribute to the reduction of ammonia emissions, not only in the livestock sector, but also in biogas plants and also in compost processes. We think that the results are very successful and satisfactory, and in spite of the fact that there's still a long way to cover until the moment when we have this technology already operating in processes, liberating and releasing ammonia and other gases. This project has been very important when it comes to finding solutions to this problem of emissions. Our objective as a foundation is to continue supporting the University of Valladolid and the society as a whole, and to work together with them the pathway of innovation and technological development, and to give them all the support that we can offer. As the rector said yesterday, it is important to highlight also that for the last 10 years, the University of Valladolid has coordinated through the General Foundation 3 projects co-financed by the LIFE program. with an average duration of 4 to 5 years, and has also been a beneficiary in 4 other projects. From the foundation, at the foundation, we're going to continue supporting these initiatives and bringing value to the development of these initiatives. I would also like to thank the participation of all the partners and coordinators of other projects who are pursuing similar goals. And it is our intention to continue keeping in contact with them and cooperating with them when this project ends in 4 or 5 days, on the 30th of September, in what we could call the afterlife plan. It's important to say this because it's important to have into consideration the fact that these projects are not a goal in themselves. In most cases, they open the pathway for innovation, a pathway that we need to walk until that technology, that innovation achieves a optimum level of development, and it can be start operating in the market. So I declare closed these technical workshops, but before I do that, I want to thank all of you for your participation, and I hope that the presentations have fulfilled your expectations and have been a useful tool to let you be more familiar with all that has been done to solve the problem of ammonia emissions. And let me just tell you that the website www.ammoniatrapping.com is going to include soon all the PowerPoint presentations and all the resources, and even the recording of these technical workshops. Of course, thank you very much again for your attention to all of you who have taken part in one way or another in these technical workshops. And I would also like to state that for the University of Valladolid and this foundation, it is very important to have the opportunity to take part in this type of initiatives and to contribute to building a better world for us who are living in this world at the moment, and for coming generations especially. And we need to work and raise awareness about the emission of gases that contribute to climate change. Sorry. I apologize for that. It's contributing to climate change and also to global warming and to the greenhouse effect. The last few years have been the hottest years in record, and well, this is a problem, of course. Okay, so I hope you have a great weekend. And as Maria Jesus has already said, hopefully we'll see each other in the future in initiatives like this. Thank you very much.
Raúl, no sé si me oís alguien o no.
Sí. Encantado por tus palabras. Creo que ahora tenemos una intervención de...
Raúl, can you hear me? Yes, thank you very much for your address. I think that Rocío Blanco is going to take the floor now.
Hola.
Hello.
Hola. Simplemente yo, en nombre de la organización, quisiera pues dar las gracias tanto a
On behalf of the organizers, would like to thank
estos 2 días como
the speakers,
a todos los participantes en las jornadas. Solamente, bueno, aparte del agradecimiento, porque creo que bueno, que hemos tenido unas jornadas magníficas.
And also,
todas las ponencias han sido de altísimo nivel. Solamente
I would like
indicar
to
que en los próximos días
say
recibirán un
that in the next few days you're going to receive
a la página web del evento.
Link to the website of the event.
Ay, perdón, que no estaba conectado mi vídeo, perdón.
Sorry, my video is not
Bueno, en los próximos días recibirán
okay, so in the next few days, you're going to receive a link
a la página web del
to
evento,
the
donde
website of
colgaremos
the
todas
event where we are going
todas
to
las
upload
ponencias
all
y
the
toda la información relativa a esto.
PPTs and
Reitero
all the
mi
information
agradecimiento y
related
bueno,
to
creo que esto
this
ha
event.
sido un
So
éxito
again, thank you
y
to all
esperamos seguir
of you.
viendo pues,
This has
todas
been a
estas
success, I think, and
tan
I hope to
importantes
see you
para el
again
progreso de todos.
soon
Muchas
within the
gracias.
framework of all these initiatives that are so important for the progress of all of us in our society. Thank you.